Hello everyone, this is Abdullah, and I will show you, I'll present to you the Cadence tutorial. You will be watching these series of videos to learn Cadence, how to open it, how to run or actually build a circuit, and how to run analysis, and as well as doing layout. But for now, I will show you how to open Cadence and build a circuit and do some analysis. So first up, in order to access Cadence, you'll need to follow a couple of steps. And the first step is to download FortiClient VPN. So FortiClient VPN, and click on this. Go down to, I already shared the link with you, but go down to FortiClient VPN and download for Windows. Or if you have Mac OS or Linux, download the corresponding one and install it on your PC. And the next one is to go into MobaXterm download, select this link, download the free one, and install it on your PC. And you'll basically have two softwares to use in order to access Cadence. Now, never mind these. Let's start up the FortiClient. After you installed it, start it up and configure your settings to have. So for FortiClient VPN, you need to follow a couple of steps. And the first step, which is downloading the VPN itself, FortiClient VPN only, and for Mac, you need to follow this instruction, but I'm using Windows right now. And after you download and install FortiClient VPN, you need to create a new VPN connection or configure your VPN connection and create it according to this. So you need to name the connection name as uConnect and the description as ULVPN, and then remote gateway as the uconnect.louisiana.edu, and check customize port and enter 10443. Select prompt on login, and that's it. Just save the configuration, and then you'll go to the main window and you'll type in your C number. You'll choose the VPN name as uConnect, and then type in your password. This password is the password you use for your email access or your Moodle or Ulink access. So the password is always the same. When you change it, this changes as well. It doesn't stay constant throughout your. Yeah, it's always the same password through every account you have on school. So after you do that, so for me, I have uConnect, I put in my C number, and note that you should type in the C as a capital, and type in the number, and then type in the password. For me, let me type the password. So after I type the password, click on connect, wait for it to connect. There we go, we have a connection to the school server. Now the next is to open up MobaXterm. So after you download and install MobaXterm, open it up and you have this window. So for now, you'll be using SWAMP 30 to SWAMP 34. Do not connect to the other two. You'll not have, these are the computers that you need for accessing Cadence. So SWAMP 30 to SWAMP 34. So in order to add these into your sessions, you need to go into Session, SSH, type in the name that corresponds to here. In our case, it's swamp 30.cmix.louisiana.edu, right? Let's do swamp 29 for now, just to show you guys how to do it. So I typed in swamp29.cmix.louisiana.edu, and then the next step is check on specify username, and here you should type in your C number as well. So C, mine is 5386, 34, and that's about it. That's all you need to do in order to connect to the machines at school. And then you click on OK. So click on OK. It will ask you for this. Just click on accept. And it will ask for another password. This is the same password you have for all your C number accounts. So ULID accounts. So type in your password and hit enter. It will ask if you want to save the password. I recommend for if you want to save it, you could save it. If you don't, you'll have to type in your password every time you want to log in. I kind of save it all the time, so I click on yes. So apparently what happened is do not use 29, use 30, 31, 32, 33, 34, but do not use 29. So I'm going to delete this session. So delete this session. And I'm going to start swamp30.cmix.louisiana.edu. So in order to do this again, I'm going to go through the steps to create this session. So click on session, SSH, type in this, swamp30.cmix.louisiana.edu. Do not type in the C number, just type swamp30 .cmix.louisiana.edu, and then click on specify username and type in your C number 53, 56, 44, and then click on OK, and that will let you access this machine. I won't click on OK now because I already have it, but you guys click on OK in order to access it, right? So after you do that, you'll connect to swamp30. It will ask you for a password. Just type in your ULID password and that's it. You will have access into it. So for now, let's list stuff. Let me do some couple of stuff. Whoops. VLSI test. Let me just remove that for now. But in order to delete a directory, you need to do this. Okay, so first step is creating VLSI test 2. For me, it's 2. For you, it's just VLSI test. I already have the folder. I just want to show you the steps to create one. So make directory, VLSI test 2, press enter, list. Do you have VLSI test 2? Yes, you do. It's right over here. So cd into VLSI test 2, autocomplete with tab. You're inside. Now, the next step is to copy Cadence WGPDK, and then you got att21885.cshrc. So copy this inside your directory. So you type in this directory and then type a dot after putting a blank in between. This will copy that file inside your directory. So the next step is to type in tcsh in order to go into Turbo C Shell. Right. After you enter that, you'll have square brackets and your C number as well as directory in between those square brackets. So for now, you will source that .cshrc file. So source and then type in att tab and then do it. All right. Just in case, do it again. Okay, it already sourced the file. That's good. Now, the next step is to open up Virtuoso. So in order to do that, type in Virtuoso. ampersand. The reason for the ampersand is to run it in the background. So actually, if you want to run other stuff in the background, you type in the ampersand. If you don't type in the ampersand, you won't be able to run other stuff inside this terminal or the Unix terminal itself. So I recommend typing in the ampersand and then just hit enter. It should be opening Virtuoso anytime now. So yeah, this pops up as well as this. So you got your Cadence up and running. You'll have to wait a couple of minutes just for the Cadence to configure stuff up. Yep. All right, so you got two screens, two windows. One of them will show you the library manager, all the libraries that you got. The other one is the terminal or the command interpreter window, the CIW. We will mostly work on the library manager. So here, just browse through the libraries and see what we have inside. So this is the analog lib, the GPDK045. You got sheets. We don't use this much often. CDS def, techlib, basic. We don't use these most of the time. But basic and analog lib, yeah. And GPDK045 is where we have all the MOSFETs that we need in order to build a circuit. So the first step here is to create a new library. So File, New, and then Library. And then name anything you want. I recommend naming it VLSI test. And then hit OK. So a window will pop up, this window, and it will ask you for a couple of stuff. Just check on attach to an existing technology library and then click on OK. Another window will pop up, and then here you'll click on GPDK045 and then click on OK. So now you got the library created here. And the next step is to create a cell inside this library. So here in the column here, you'll have lots of cell views, right? So every cell views, you'll be having inverter, AND gate, NAND gate, OR gate, and so on. So you'll have lots of around maybe 12 to 14, depending on the assignments you got. But overall, this is the place where you will be working on. So first up, we'll go through creating an inverter and analyzing it. So first thing is to create a cell or a cell view. So new, file, new, cell view. And you got this window popping up. So inside the cell, you'll type in the name of the circuit that you're going to build. So for now, we will build an inverter. And I will call the inverter shortly as in INV. So INV or INV. And then I'll say OK. Click on OK. It will create the cell view. Now this cell view, keep in mind, we created the cell view in schematic mode. So this window will pop up. So this is the schematic window, and this is where you will be building the circuit itself. So for now, let's expand this window. All right, so here is where you will build lots of circuits. But for every circuit will have its own cell view. So for now, let's build the inverter. Let me just tell you about a couple of things here before we move on. Zooming in now is really efficient here. So it depends on where the cursor is, it will zoom in towards that place. So if you bring the cursor into the middle, it will zoom equally from all sides. Bringing it to the top will zoom to the top rather than zooming in to the middle. So the first step is to put in or insert an instance. So inserting an instance in Cadence is, so in Cadence we usually use hotkeys rather than going and navigating through these buttons. I recommend that you use hotkeys. So adding an instance into the schematic is when you press on I, a window will pop up. So pressing on I for India will open up the instance window. So here is, you will have library, cell, view, and then names. In order to insert the MOSFET, so an inverter has two MOSFETs, one PMOS, one NMOS, and we'll have to build that. So let me show you. So this is the inverter, and you have the circuit here. So we want to build this circuit, right? We got one PMOS and one NMOS. And we will analyze this circuit. So let's insert a PMOS and an NMOS first. And then we'll move forward and connect to them and adding the power rails, or basically the VDD and the ground. So let's go back to the schematic and let's add a MOSFET. In order to add a MOSFET, you need to navigate to GPDK045, and then inside the cell you have lots of devices, but the ones we use is PMOS1V, and if you scroll up you got NMOS1V2, NMOS1V and PMOS1V. So let's select PMOS1V. If you select that, you could see lots of factors inside. So you got the multiplier, the length, the finger width, total width, fingers, and so on. We usually use length and finger width in order to adjust the width and the length, the channel width and the length of the MOSFET. Multiplier is just the number of this is usually default as 1, is set as 1 in default, as well as the fingers. Number of fingers is 1 as well as a default. But for now, we will use length and finger width, but we will not change them. And we'll keep them 45 nanometer and 120 nanometer for all our designs. So for now, just keep these the same value, the default value, and then insert your MOSFET. So let's zoom in a little bit and put in our PMOS. So I put my PMOS. I just clicked once to insert it, and then I click on escape. Just escape the insertion of PMOS. And I want to add NMOS as well because inverter has a PMOS and an NMOS. So I'll press on I again, and then I'll navigate to NMOS. So for this, you could either go through the list and select the NMOS. What I do is I delete the P and then type in the N, and guess what? It didn't change. It didn't change the view itself. This is still a PMOS, even though I typed in an N. So keep in mind that after you change this name, press on tab just to change the device itself. So when you pressed on tab, the device here changed from PMOS to NMOS, and now you have the device itself. So Once you have it, place it anywhere you want, just as long as it's a bit further away from the device, from the PMOS itself. Place it there, and then we press on escape to escape the insertion mode, the add instance mode. Okay, now you have PMOS and NMOS devices here. Now the next step is to connect them, right? So we have a connection between the gates and a connection between the drains and connection of source to the power rails. For the case of NMOS, it's the ground. Case of the source of the PMOS is connected to VDD, and then we will label these wires as well. So let's do that. So for connecting, before we move on to connecting, you want to move these MOSFETs. Let's say you place them in a wrong spot, or I place them a bit far away, right? You want to move these MOSFETs. So in order to enter the moving mode, you have to press on M. So M, and then you enter the moving mode. Note that you have like next to the cursor, there are lots of symbols that show up when you enter a mode. So in case of the moving mode, when I typed M, I entered the moving mode and it showed a symbol next to the cursor, right? So we want to move stuff around here. What do? We enter the mode, I click once, and now I'm moving the device itself. Let's say I want to move it close here. I moved it closer. If you want to move it further away, you can do this, click once, click again, and I placed it. I could do this all around the place, just move it around, but I want to place it here. You could also, in moving mode, what you could do is highlight whatever device you have, and then click again in order to move it. Move all devices. Another thing is the copying mode. So if you want to go into copying mode, it is C. So press on C, you got the copying mode on. Now you want to copy these stuff, right? Highlight them and then click on them. Now you got two pairs of course, I didn't place them yet, but I copied the devices, and that's how I place them. Now, escape the copying mode by pressing on escape button. Now I want to undo this. I could either delete, so by highlighting delete them, press on delete button, or I could undo these by pressing on U for undo. U. So I pressed on U, I undid my previous step. So moving forward, you got multiple hotkeys. I recommend that you note them down. But for now, the next step is to connect these MOSFETs, right? Accordingly. So let's go into wiring mode. So for wiring mode, you need to press on W. So press on W. Now I'm in the wiring mode. Come here, I click once. Do not click and hold your click or hold your mouse button, but just click once. So click once, clicked again, and now I connected to the gates of both MOSFETs. I want to connect the drains of these MOSFETs as well. So the PMOS and NMOS. Click once, click again, and now I'm done. Now another thing here is to, in digital circuits, we always, or most of the time, we connect the bulk terminal to VDD and of the PMOS, and the bulk terminal of the NMOS is always connected to ground in digital circuits. So keep that in mind, but for now, let's do this. So before moving forward, I want to insert a couple of sources. And when I mean sources, I'm talking about the power rails of both of these, the PMOS and the NMOS. So for now, let's add a source. So escape the wiring mode, press on I. Now I want to navigate to analog.lib. So from the drop-down list, you got analog.lib. You could either select that or type in analog.lib like this. So analog.lib and then tab. You're inside the analog.lib or analog.lib library. And then inside that, you will look for VDC, right? You could either drop down the list and look for VDC itself, which is here, which is a long way down, or you could just type in VDC and hit tab. So now you got this VDC source or the DC source, and you want to place it on the schematic. So for now, let's type in the DC voltage. You could either do it here or you could do it from the schematic. So for now, let me show you how to edit the properties. Once, let's say you accidentally place this, or not accidentally, you intentionally place it like this, and you want to edit the properties of this DC source. So let me escape this, add instance mode, go inside the DC source and edit the properties. You have to press on Q. So this is another hotkey. Press on Q after highlighting this source, and you've got the edit properties or edit object properties window open up. So here is where you will set the DC voltage value of the DC source. So for now, let's put 1 volt. And let's click on OK. And here is how I set the DC value of the voltage source. So now I want to place it a little bit down here. That's how I did. What I did is press on M and then click on this and then move it down. And I escaped the wiring mode. And the next is I want to put another source here. So what I did is I pressed on C. Let me do this again. So I pressed on C, hit C, and then click this DC source. Move it here. Click again to place it. That's about it. Now you got 2 DC sources, right? The first one I'd like to connect is this. So this is the VDD source. I'll connect it. So you could either do this or you could go a little bit up, click again, and click again to connect this, right? Okay, and the next step is to connect this here and here. And then we got this connected to here, this, here. Are we done with the circuit? No, we're not. We'll have to connect these terminals to VDD and ground as well. So before we do that, I could either do this and connect it here, and then we have the VDD itself, right? We connected the bulb terminal to VDD, or do this the same and connect it to ground. Oh, by the way, we didn't create a ground rail yet. So there are 2 ways to create a ground. The first way is to open up the add instance, go to analog lib, and then go to find ground, or basically GND. This is it. Tab. And this is how you could create a source and place it. I recommend do not place it on the wire itself, but place it somewhere else. And you could just connect this ground to the wires, and there you have it. You have a ground now. What I do most of the time is not this. I'll show you another way which is better, and this way is called labeling. So I press on L for label, and this will show up. So inside the label, we want to label every wire we have here, right? So for now, I want to label all these wires or all these nodes. What do we have? We have the input, we have the out, we have GND, and remember, to make it a global ground, we type in GND and an exclamation mark. And lastly, we have the supply voltage, or VDD, right? After you type in those, click on hide. What showed up first is the first label you typed in, the blank, in the blank field. So we got in, this is out, ground is here, and we got VDD. Okay. After you do this, click on or press on escape to escape the labeling mode. Now the second step, now that we did this, we can connect the bulk terminal to here, or we could just create a wire next to the bulk terminal, which is more convenient in terms of spacing, right? In terms of less complexity as well, or clarity. So now we want to create a wire here and show it as a floating wire, right? So I clicked and then I double clicked to create a wire here. I could either do the same for this, just click and double click, or I could copy this to make things faster. So now I created two wires that are floating, but I want to connect them to a node here. So how do you do that? Press on L for label, type in VDD, type in ground, exclamation mark, then click on a hide, click, and place these labels on top of the wires. So you got VDD on this wire, and you got ground on this wire. Now what happens is this wire is not floating anymore. It's connected to the ground node. So as if I'm actually connecting this wire to this, but I don't need to anymore because I named this wire as ground exclamation mark, and it is common to this node, which is ground exclamation mark. Oh, by the way, to pan this view, you could click the middle button of the mouse in order to move the screen itself instead of zooming in and zooming out. It is convenient as well. So here I did the same for the bulk terminal of the PMOS. I connected this terminal to VDD, and that's what I did. I created a wire, I labeled it as VDD, and this shows as you don't have to. So this is a convenient way of actually connecting these terminals, right? So for now, this is how you build a circuit and how you add sources. The next step is to analyze the circuit